Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be showing you tonight will be the conversion of a single voltage output adapter to a voltage output which is variable. Okay. The output of this adapter here is 12 volts at 2.5 amperes. And what I did is that I converted the output of this one. So if I needed a voltage which is 3 volts, I could do it. What I did is that I got a breadboard here, and I got the components of the adjustable voltage regulator now is an LM370 voltage regulator. The voltage of this one, the voltage output of this one is variable, and this will be the configuration, and these are actually the values I use. So I got an LM317T with the terminal specification 1, 2, 3. Terminal 3 will be the voltage input, terminal 2 will be the voltage output, and terminal 1 will be where we will connect a potentiometer to adjust the voltage output. So if we try to bring out the schematic diagram of this one to bring out the variable output voltage, this will be the schematic diagram. This one here is the LM370. This is the potentiometer. I connected R1 here, 240 ohms. That's a fixed one. But this portion here, if we try to rotate this one from 0 to maximum, we could adjust the voltage output. That's the main concentration of this topic for tonight. By rotating this R2 here from 0 to maximum, we could adjust the voltage output here. So what I did, I placed it already on a breadboard. So this is the LM370 with the, supposed to be it got a heatsink, but since the current consumption of this is not too much, I didn't place any more heatsink. It got a heatsink itself, but if we try to put a metal thing here, that will be better for it. This is the potentiometer in which we will adjust the voltage later. This is the 240 ohm resistor. And this portion here, I place a big capacitor on the output. It's not 0.1. I place a 470 microfarad 16 volt capacitor on the output. So it got so much what you call this storage capacity while it is bringing out a voltage, you know. If you place a capacitor on the output, it seems it got like a savings of power needed for the load, you know. Okay, so what I did is that I got the polarity of the output of this one. The first portion here is this one. It goes to the input and it is connected to terminal number 3. Terminal number 3 facing like this. This is 1, 2, 3. The one on the right is terminal number 3. So the positive terminal of the adapter is connected to terminal number 3, and that's the power input going to the voltage regulator. The negative terminal of the battery, of course, it should go to the ground, the positive terminal. And if you could see the breadboard, this blue thing here is the ground. These are all ground from left to right. And the positive terminal of the breadboard is actually the one with the marking red here. So all these holes here from here up to the right are all positive terminals. So if you would like to connect a minus, just take one of the holes here. So actually the negative terminal of this one is actually this one. Where's it? This one. Okay. This is the negative terminal coming from the adapter. It goes here. It goes to the output also. Because if you try to look at the schematic diagram, this is the negative terminal. The negative terminal of the input is same as the negative terminal of the output. So if we try to bring out now the output, this negative, this should be negative. This red thing here is actually the positive terminal. The potentiometer, I place a 50K potentiometer. I just need 2 terminals to vary the resistance. So the third terminal is not connected. It's only the middle portion and the left portion. I will repeat it. This is the LM370 voltage regulator in which the input is 12 volt and we could adjust the output voltage from 1.25 to something like near 12 volts. Okay. This is a 240 ohm resistor. This is a 50K potentiometer. So by using the breadboard, we don't have to solder anything. It's just like a plug-in thing like this, you know. This came from the ground. You just remove it like this, okay? And if you want to make the connection on the ground portion is the blue one. So take any hole on the blue, okay? And that's it. It's connected already. Okay, let's try to see if the voltage output of this one is really a variable thing. Because originally this adapter, without this voltage regulator, the output is fixed at 12 volts. But by using the LM317T voltage regulator, by adjusting a potentiometer, we could adjust the voltage from 1 point something to almost 12 volts maximum. Okay, I will try to rotate the potentiometer. I will try to lessen the voltage. I think that's the smallest voltage that we could bring out. Okay. So if we try to rotate the potentiometer clockwise, gradually, it's going up, right? So if you needed to operate a transistor radio with the voltage specification of 3 volts, that's almost 3 volts, right? We could use this one to operate a small transistor radio with the voltage specification 3 volts. So if I will try to decrease further the resistance, I will be increasing the voltage output. Okay, 4 volts, 5 point something, 6 point something, 8, 9. So if you got a transistor radio in which the voltage specification is 9 volts, we could use this one. Okay, just set it very near 9 volts and you could use this one. So this one is actually a very good design because when we needed the 9 volts, we just rotate the potentiometer and we could obtain 9 volts. Let's try to see the maximum voltage that we could bring out from this. Uh, the voltage output is just limited to very near 12 volts because the maximum voltage we input on the regulator is just 12 volts. So just in case the voltage input is 24 volts, we could vary the voltage from 1 point something to around 24 volts. But this one, since the voltage input of this one on the input of the regulator is just 12 volts, the maximum voltage that we could obtain is just, it's almost 12 volts. $11.42, right? So the voltage input on the input of the regulator is 12 volts. The maximum voltage that we could obtain on the output is 11.42. And like what I said, we could lessen this one. Okay. The output is variable. Right? Okay. So as we rotate the potentiometer, the voltage output is decreasing. So this is a very good power supply because whatever voltage we need from 3, 6, 9, or 12, we could use this one. Okay, this is a breadboard in which we don't need any more a circuit board because this breadboard here got some terminals, and to make the connection, you just need terminals like this. Okay, you buy this from Amazon. Okay, I think that's all the one good for tonight. This is an illustration on how to convert a fixed voltage output adapter to a variable output by using an LM317T voltage regulator, in which by adjusting this resistor here, we could adjust the voltage output. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.